Right on the topic, gravitational field. So the gravitational fields, what is the gravitational fields? Gravitation field may, is the result of the attraction between the masses. When there is a two masses, M1 and M2, there is a attraction force between them. When we are in the earth surface, the earth attract uh, man with gravitational force. We know that, right? The forces between these forces are mutual and they are attracting each other. This called the gravitational forces, and this field is called the field which may caused from the which may cause because of the mass. That's called the gravitational fields. Okay, write down. Gravitational fields occur due to gravitational fields occur due to masses of the object. Masses of the objects. Masses of the objects. Masses of the objects. Right. Write down the topic. Newton's law of gravitation. Write down the subtopic. Newton's law of gravitation. This may occur due to the masses of an object. This is the attraction force, right? We know that thing. The Newton law of gravitation also said the attraction force between two masses. What is the dependent variable that two between forces between the M1 and M2 masses? When we are on the earth, when the man standing in the earth, the gravitational force is higher, right? The attract is in the force. This is called the weight, right? In all the cases, we call it weight. Then the force which acting on the man is the gravitational force, right? The gravitational force occurs due to the earth, right? Earth. The earth is very large object and it having a large weight, right? The weight is higher. Because of that, the force is higher, right? You can force එක වැඩි, ඇදලා ගන්න force එක වැඩි, right? Therefore, this gravitational field, the gravitational force depend on the size of the masses. That means the force F depend on the masses M1 and also the M2. That calling, it is proportional to the multiplication of M1 and M2. Right? Newton said that. Newton කෙනෙක් කෙනා තමයි කිව්වේ ඒ කියන්නේ මේකේ force එක මේ mass වල මේ multiplication එකට proportional කියලා. Right? It's proportional to the mass. And also is proportional inversely proportional to the distance between the square of the distance between two masses. Square, right? Because of that, we can simply say F proportional to the M1, M2 and R square, right? The gravitational force proportional to the mass, multiplication of the mass and the distance of the each two masses, right? Therefore, we can equal them using the constant, using the G as the constant. Here is the Newton's gravitational constant, right? Constant, universal constant. Right. This is the force. Force between two masses. F equals 3m1 m2 over r square. This is force between two masses. Right? The force F and F are both are same. Both are same. This F act to the m1 is coming from the m2. Right? The force එක මේකේ action එකක් වගේ. ඒ action එක reaction එක තියෙන්නේ මේ force එක. They are action and reaction forces. Both they are action and reaction pairs, right? When we are studying the force equilibrium, we know the action and reaction forces are happen like this when we place the masses on the earth. There is an mg and also the reaction force, action and reaction pairs, right? The action and reaction pairs, right? And also when we are hit the wall by the hand, the force on the wall, the force on the hand, these are action and reaction pairs. And also, these are also the action and reaction pairs. These are also the action and reaction pairs. Do we need to consider action and reaction pairs? If we consider the action and reaction pairs, the only the two, again, make the two objects tama ඕනේ two objects වලට තමයි action එක object එකකට අනිත් reaction එක another object එකකට. There is no only the action and reaction force acting on one single object. හරි action and reaction force එක single object එකට act කරන්නේ නැහැ. Why? Let's consider the centrifugal force and centripetal force. They are not action and reaction pairs, right? It's only acting to one object, right? Likewise, these are also the action and reaction pairs, but they do not need to contact each other. Gravitational force is not contacting, right? If they are not in contact, they are also the gravitational force. Why? When we are going from the earth with some distance, we are coming to the earth. Why? The attraction between the earth and the ourselves are in there, right? But not it is in contact, right? These are action and reaction pairs. So the forces are F and F are equal to each other. This is the Newton's gravitational force. G is the constant. This is a universal constant. In everywhere, G is the constant. 6.1 into 10 to the power minus 11, right? Okay, write down the theory. The gravitational force, write down that. The gravitational force of attraction between two particular M1 and M2 masses, M1 and M2 masses, which situated at a distance symbol R is given by write down this, draw this diagram and write down this one. These are the action and reaction pairs, right? Okay, then write down where capital G is universal constant, where capital G is universal constant, which known as gravitational constant G equals 6.11 into 10 to the power minus 11. 6.67 into 10 to the power minus 11. Minus 11. What is the units? Newton. Newton. This one goes to this sphere. So the m square kg minus 2. Kg minus 2. Okay. Find out the unit. Find out the dimensions of G. Find out the dimension of G. Okay. How can we find the G? G equals, from this we can tell, G equals FR square over M1, M2. Then we can tell F R square M1, M2. MLT minus 2. MLT minus 2. L square M into M. Therefore, it's cancelled out, right? M minus 1, M minus 1, L cube T minus 2. Yes, your answer is correct. Right. Basic units are basic units of G. Kg minus 1, M cube, S minus 2. Derived units. G equals N M square Kg minus 2. In universe, this is the universal constant. That means it is same in universe, right? Okay. Then write down the gravitational field has been the gravitational field has been introduced as concept of gravitational force
ඒකාකව කියන්න පුළුවන්ද?
the interattraction between two masses is considered
Sir,
the result of the interaction between two masses
sir,
when they intersect. Right. Then write down the properties of gravitational force. The properties of gravitational force. Write down the number 1. It is an attraction force. Number 2, it acts the intercept line of two masses. Number 3, it is a mutual force. It is a mutual force. That means mutual mean the force act on the M1 also and the force acting on the M2 both are equal. Hare? Both are equal. Write down the force acting on symbol M1 and the force acting on symbol M2 are same. Are same. The gravitational field has been introduced as a concept. The gravitational force, the interaction between two masses, is considered the result of interaction between two fields when they intercept. Right. These are the properties of the gravitational field. Okay. Let's do the problem. Do the problem. Let me write down the problem. Three object of masses. Symbol M each are placed. Symbol M each are placed at the three corners. At the three corners. Where is this? Corners of triangle. Triangle. The triangle which having a length simple D to each base. To each base. ඒ කියන්නේ මෙන්න මෙහෙම points තුනක place කරලා තියෙන්නේ. This is M, this is M, and this is M. Okay. Calculate the resultant force. Calculate the resultant force on any mass. On any mass. Calculate the resultant force of on any mass. Right. Like this. Okay. The whose masses are placed on the triangle which having the length symbol D. Okay. Then we will find the force on a unit mass. Force on the mass. How can we find that? We know the lengths are equal, so the angle is 60 degree. 60 degree, right? Then we will find what are the forces. The force between M and M. We tell it is as F. The force between M and M is F. We know F is G M M over R square. That means D square. G M square D square. Okay. Then also the forces between these two masses are same like this. F. This also F. This also F. Then find out the force, resultant force which acting on the single object, write down the resultant force which acting on the single mass in term of D and symbol M. D and simple M. Okay. Karana ba? This is the equilateral triangle, right? Equilateral triangle, and forces between forces only one object, one simple M mass, F and F. Both are acting in 60 degrees to each other. How can we find the resultant of that one? How can we find the resultant of that one? We have to take the summation of that. We have to take the summation of that. How can we find? Let's consider this one, this object. This is M. Forces are acting F and F. What are the angle? Angle are 30 degree, 30 degree. Okay? 30 degrees. Then we have to find the components of these forces. How can we find these components? How can we find these components? See, F sine 30, F sine 30, they are cancel out. They are cancel out, right? When they are cancel out, then we can find the resultant, right? They are cancel out, right? F sine 30 cancel out to this F sine 30. F sine 30. Then F cos 30, F cos 30. That means 2F cos 30. Right? Is that clear? F 2F cos 30. Okay. Right. Then the resultant on one on a single mass, on a mass, equal FR equals to the, that means FR equals to the 2F cos 30. That means 2F, F mean what? G M square D square cos 30 mean root 3 over 2. Root 3 over 2. Root 3 D M square over D square. Right? Like that. Okay?
Yes.
Right. Write down another problem. Write down the problem. Find out the write down the problem. Find out the magnitude and the direction. Magnitude and the direction. Magnitude and the direction of the initial acceleration of mass as shown in figure. Assume that only the gravitational force extracted by A and B
Extracted on
A and B, capital A and B, on the mass capital P, only the gravitational force extracted A and B on the mass capital P. A and B masses are stationary. A and B masses are stationary. A and B masses are stationary. Right? Like this. They are stationary. A and B masses are stationary. This is A mass. A. It is 6.4 kilogram. And this is 6.4 kilograms. Right. They are stationary. These two masses are stationary. When this is simple M mass, when we released it from this end, what is the acceleration, initial acceleration, the object? Find that the distance between these two masses, 8 centimeter, 8 centimeter. Okay. Find out the acceleration on this M object. Right? Okay. Only the force acting on the symbol M is the gravitational force. We have to mark that F. And also we have to mark that the two forces. And also we can mark theta. Theta. Okay. Then you have to draw the triangle theta. This is theta, 6 centimeter, 8 centimeter. This is 10 centimeter. Why I do like that these things? Because we have to know the sine theta cos theta values. Right? Okay. First of all, we have to mark these forces. Then we have to take the force. How can we take the force? If F and F are equal, right? F acting M and 6.4, which are in distance with 10 centimeter. Also, this also M and 6.4 kilogram, which are acting in 10 centimeter distance. Right? 10 centimeter distance. Likewise, we have to take F is equal to what? F equals to D M1 M2 over R square. That means F equals to G. I not substitute that G as the value. I get that in G by the calculations. If I take that one, it's very difficult to substitute. M, this one 6.4 R square means 10 centimeter square. That means 10 into 10 to the power minus 2 square of that one. Okay. They are the force. And what is the acceleration? If you clearly see this one, see what is the direction of acceleration? The forces are F and F. Both are acting with theta angles to the vertical. The F, the component of this, the horizontal component, F sine theta. The horizontal component, F sine theta. Right? Because of that, F sine theta, therefore, we can tell this is F sine theta, horizontal, F sin theta and F sin theta cancel out. Only the direction, the force acting on the vertical direction. Vertical direction. See, F sin theta cancel out. Only the force acting on the vertical direction. That is F cos theta, F cos theta, 2F cos theta. Therefore, resultant force acting to downward direction Fr equals 2F cos theta. 2F cos theta. Right? 2F cos theta. Okay? Then find out what is the value. You have substitute G equals to what? Finally, you have to substitute that one. Okay? Not initially. G equals 6.67 into 10 to the power minus 11. Right? N m square kg minus 2. Okay. Finally, yeah? Right. So, you have to substitute this one. Now substitute G. Why? It's very difficult. 6.4 into m into G 10 to the power minus 1. That square means 10 to the power minus 1 is 0.1. 0.1 square means 0.01. mg 0.01. Alright. FR mean the total reaction force, total resultant force. So the full F means 6.4 mg 0.01. Cos theta. What is the cos theta? That's why I am doing like this. We can simply say sin theta. What is sin theta? This is not need, but I am just telling. Theta is equals opposite hypotenuse 10. Right. Cos theta, that means 6 over 10. So you have to substitute that one. Right. We have to substitute cos theta. Cos theta means 6 over 10. Like that. Okay. This is FR. Only we can do what? We can only say 2 into 6.4. This is 0.1. That means 64 into 6. I'm not substituting. Okay. Like this. This is the resultant force. Therefore, apply F equals MA to the downwards. That, what is the downward direction? F equals MA. F means FR. That means 2 into 64 into 6 into mg equals MA. Substitute. The A is equals to 12 into 64 into G. G means 6.67 into 10 to the power minus 11. Right. What is the value? The acceleration. What is the value? Like that. Finally, we can substitute that. Yeah. I think your answer is correct. Twelve into 64 into 6.67. 51.29 into 10 to the power minus 3. We have clearly go 51.23. 51.23 into 10 to the power minus, I think 9 or somewhere. This is the calculation. It's okay, but you have to memorize the way of this doing. Right? It's very simple. You have to only use this equation. This equation. We are only discussing that thing, no? Make a විතරයි අපි කතා කරේ. Right. Very easy. But the concept, concept. You have to use the concept. Okay. Then write down. Then write down. Let's move to the theory. Okay. Okay, write down the another topic. We are only discuss the Newton law of gravitation. That means this equation, and we only from that we can do the any problems. Okay. Then write down the another topic. Intensity. තීව්‍රතාවය කියලා කියන්නේ. The gravitational fields. Intensity of gravitational field. Gravitational field intensity. That mean the power of the gravitational field, like that, right? It is the intensity, right? That means the strength of the gravitational fields. When we are measuring the intensity, we can tell the gravitational when the gravitational intensity is high, gravitational strength, field strength is high. In in somewhere the earth, there is a gravitational force. The strength of the gravitational force may vary. In Sri Lanka, the gravitational force is lower than to another countries. There is some geometric centers are in that's not in our syllabus. If you search that one, you can see the gravitational intensity and the gravitational strength is less than in our country. Right. Write down the strength of gravitational field. The strength of gravitational field at any point. At any point in it's measured by at any point and it's measured by the quantity known as gravitational field intensity. Gravitational field intensity at that point. At that point, the intensity of gravitational field, at such a point, is the force acting on unit mass, which placed at that point, That means when we are placing symbol ms in the gravitational field, there is a force acting on the ms. Why I claim like that? We know when we are placing symbol ms on the earth, what will happen? There is a force acting. Why? there is a gravitational intensity. That means G. G means in the units of G is n kg minus 1. You know this one. Why? You know when we take the 5 kilogram of mass, we mark what? Weight. Why? It is as 50 Newton. Why we are using the 50 Newton? That's why we are know the gravitational field intensity is 10 n kg minus 1. 10 Newton per 1 kilogram. 5, it is 50. Like that. The gravitational field intensity is that one. G. You know, this one is very easy. Like that. The gravitational force F equals mg. mg. Therefore, the gravitational field intensity equals force per unit mass. Force per unit mass. Right? Okay. Write down. Write down. Hence, if capital F is, the force acting on a mass simple m, simple m, placed at certain point, placed at certain point, placed at certain point in a gravitational field, in a gravitational field, in a gravitational field, the gravitational field intensity, the gravitational field intensity is of the point is right. F equals mg, G equals FOM. Write down this one. Okay. Write down this one. As an example, we can tell the gravitational field intensity of near to the earth, G equals n kg minus 1. When we place the 2 kilogram, the gravitational force intensity G acts as n kg minus 1. That means the force F equals mg means 2 into 10, that means 20 Newton. Okay. Let's write the gravitational force intensity, the gravitational field intensity is 10 n kg minus 1, is 10 n kg minus 1 near to the earth, near to the earth, near to the earth. Therefore, when we place the 2 kilogram of mass, when we place the 2 kilogram of mass near to the earth, near to the earth, in brackets weight acting on the mass is 20 Newton. Therefore, gravitational field intensity is 20 Newton. Right. Okay, write down this one. It's very easy, huh? It's very easy. Okay. Okay. Then write down the another subtopic. Write down gravitational field distribution. Gravitational field distribution. Another subtopic. Gravitational field distribution. Distribution of a mass. Gravitational field distribution of the mass. Of the mass. Of a mass. Right? What is the gravitational field distribution mean? When we take the earth, there is the field lines. All the fields are marked by using the field line. In all science, we know the bar magnet. Bar magnet, the magnetic field. What is the distribution of magnetic field? In A level also, after some lessons, we discuss that also. What is the distribution of magnetic field of bar magnet? We can simply draw like this. What is these lines? What is these lines? We clearly see them. Why? Using the iron powder, we can simply draw and simply see the distribution of the bar magnet, magnetic field of the bar magnet. How can we use that one? We place the bar magnet under the paper, then we spread the iron powder. Then we spread the iron powder. Then we can see the gravitation, the magnetic field. Likewise, we are also we discuss in uh, here the magnetic field, right? Likewise, the gravitational, the Earth also having the gravitational field lines, gravitational fields line. How can we draw the gravitational fields line? All the gravitational field line are acting inwards to the mass. That means why inward to the mass? Why into the mass? When we place simple M mass, the attraction between masses are into this higher mass, right? It's attract the unit mass. Likewise, we can decide the direction of the intensity lines. Intensity line means the field lines. These are the field lines. මේවා තමයි මේ strength එක මනින්නේ. From these lines, we can measure the strength, right? Strength of the gravitational field. මේකෙන් තමයි gravitational field එකේ strength එක මනින්නේ. But can we see the gravitational field line? When we are going on the road, there is a gravitational field line. No, we cannot see. But the magnetic field we can see, not in a naked eye. When uh, we can show using the iron powder. But the gravitational field, there is no proving. But we can simply say the unit mass is attracting to the Earth. Therefore, the gravitational field onto the Earth. These are the field lines. Field line. Gravitational fields line. Right. Write down. Draw this one. Draw this one. Write down the subtopic. properties of properties of gravitational field line. Properties of gravitational field lines. These are imaginary lines. Why? We cannot see these lines, right? Write down the first property. Imaginary lines which are used to only get the direction, which are used to only get the direction of the field, of the field, of the field. Number two, write down number two, they do not intersect, they do not intersect each other, they do not intersect each other. Right. These they are the properties. Okay. Then write down the another subtopic. The gravitational field intensity. The symbol is simple G, simple G. Then write down the subtopic. Gravitational field intensity. Gravitational field intensity around the mass. Around the mass. Gravitational field intensity around the mass. Okay. This gravitational field intensity is a vector. Is a vector, not a scalar. It is a vector. Why? There is a direction. When we place the mass, the direction into the mass, gravitation. Likewise, we can tell when we place this one, M, near to the symbol M, it is attracting to the capital M mass. And also there is a force. These forces are called gravitational force. And also we can tell the gravitational field intensity also acting into the capital M mass. As example, we can take the Earth. Let it's Earth, biggest one. Likewise, the force acting to the this one to the center, force acting from the center, and also gravitational fields line acting to the object, like that. Likewise, right? I can simply say there is a gravitational field intensity G that called NkG minus 1. Okay. But we know what is the force between two masses. We know, considering Newton's gravitational law, considering Newton's gravitation law, I know F equals what? These are the distance R, simple R. F equals G, capital M, M over R square. This is not a doubt. No. This is only force, right? But we know field concept, right? Considering the gravitational intensity, considering the gravitational field intensity. we can simply say, F equals to the mg. F equals to the mg. Why? That before that we know this F equals to mg. When we take that as this one is earth, this force is the weight of the object. Weight of the object. We can tell F equals mg. Both are same. Number 1 and number 2 are same. Therefore, we can simply say 1 equals to 2. That mean what? Mg equals to Gmm over R square. Okay. Then cancel out. G equals Gm over R square. This is the result. That means when we take in the distance of simple r distance from the mass, the gravitational field intensity equals Gm over R square. Right? Like that. Okay. Write down. Gravitational field intensity is a vector. Gravitational field intensity is a vector. Write down the note. Gravitational field intensity is the vector. Find out the intensity. To find out the intensity in bracket symbol G. At a point outside. With simple r. With distance simple r of mass capital M. Okay. Then write down. Let consider the force on the mass symbol M. Which placed at symbol r distance. From capital M. Okay. Then you have to draw this one. Considering Newton's gravitational law, you can simply say F equals Gmm over R square. Okay. Considering the gravitational field intensity, the theory of the gravitational field intensity, F equals mg. Therefore, this first one and second one is equal. Therefore, G equals Gmm over R square. Okay. Okay, write down. Quickly, write down. I previously mentioned this gravitational field intensity is a vector. Therefore, when we take in the gravitational field intensity between the system, we have to take the vector summation. That's two the problem, right? Before that, write down. Since the gravitational field intensity is a vector, to find the average field intensity due to several masses at a given point at a given point, the field intensity is produced. The field intensity is produced by each masses. By each masses should be separately taken. Should be separately taken and have to get the summation of get the summation of get the summation of get the summation of vectors, right? And also we know, and also බලන්න අපි we know G equals G, sorry, gravitational field intensity at a r distance from capital M. The G is, we know gravitational field intensity symbol G is Gm over r square. We know that one. But you can see when we increase the r, that means we increase the length, right? That means when we get in simple m as the distance getting higher, r getting higher, g getting reduced. We know that one. The gravitational intensity getting reduced with the distance. But you know, where is the relationship? G not proportional to the r. G proportional to the r square. That means it's inversely proportional to the square of the r values. That is the another another point. Right. Write down. Gravitational field intensity. Gravitational field intensity is inversely proportional. Is inversely proportional to the radius. To the radius. Okay. Write down this one. T proportional to the 1 over r square. That means when we draw the graph, the gravitational field G, that means nkg minus 1 getting reduced with the r. Huh? Getting reduced with the r. That means it is like this. It is inversely proportional to the 1 over r square. Right? Likewise. It is inversely proportional to the 1 over r square. Okay? Okay. Write down this one. This is the graph. Huh? Gravitational field intensity getting reduced with the radius. Right. Draw this one. Okay. Let's do the problems. Huh? Let's do the problems. Okay. Write down the problem. Three masses are placed at after this one. Write down problem. Three masses are placed at ends of equilateral triangle. Ends of equilateral triangle of base length symbol D, symbol D, find out the gravitational field intensity gravitational field intensity gravitational field intensity uh, at P point. P point means this one. Base length I had given symbol D, no? Symbol D. D over 2, D over 2. Find out in terms of M and D. Yeah? This is the P point. This is the P point. The lengths are D, D, like that. Okay? Find out. How can find? You know this point, huh? What is the length? You know what is the, how can we get the length? Pythagoras theorem, huh? Pythagoras theorem. You can simply calculate the, what is the distance of x? Pythagoras theorem, huh? Okay. Find out. Acting this and acting from this. Find out the gravitational field intensity. Okay. Find out and tell. To this, how can we find the gravitational force G, field intensity to from this simple M acting on this direction. I take as this one is G1. What is the G1? G1 equals to G M over D over 2 square. G M D square over 4. 4 G M D square. Okay. What is the gravitational field intensity which coming from this M? Also it is G1, no? It also G1. Why? It is also Gm over D over 2 or D over 2 square. Huh? Okay. As I mentioned, this is very easy. Huh? G from the gravitational field intensity from the R distance of the mass equals Gm over R square. Therefore, you can see this G1 and this G1 is cancelled out to each other. Therefore, only the gravitational field intensity, I take the G2, it is acting from simple M mass in upper side. What is that? What is that? We can simply cancel out this one, no? Let's take the G, it is the answer. G2 equals G M over x square. But we didn't know what is the x. We can use this Pythagoras theorem. Hypotenuse is D. This is D over 2. And this is x. How can we find the x? Okay, we can simply say x equals to t square over d over 2 square root of that one. D square minus d square over 4 root. That means 3d square over 4. That means root 3d over 4. This is the value. Therefore, we can simply use that one. G M divide x mean root 3d 4 square. Is that correct? Yes, no? 4, no, not 4. It's 2, no? The root of the 4 is 2. That mean G2 equals GM 3D square over what? 4. That means 4GM over 3D square. This is the value. G2 equals 4GM 3D square. Your answer is correct. Your answer is correct. Right? Good. Okay. Then write down the problem. Okay. First of all, draw this diagram. Draw this diagram. One, 2 meter, 2 meter, 2 meter. Write this diagram. Okay, draw down. This is sentence O. Number 1. Find out the gravitational field intensity. Find out the gravitational field intensity. Of point. Gravitational field intensity of O point. Gravitational field intensity of O point. Number 2. Find the force where 10 kilogram mass placed on the 10 kilogram mass placed on the capital O. Placed on the point capital O. Placed on the point capital O. Okay. First of all, you have to find the gravitational field intensity of the point. Find out.
There is an easy method and difficult method. Therefore, we have to find the gravitational field intensity at O point. Therefore, I follow this method. I take gravitational gravitational field intensity at O point from 1 kilogram. 1 kilogram, what is the gravitational field intensity? To that, we have to take the 1 kilogram. What is the distance to the 1 kilogram? I take as R. The distance I take as R. What is the R value? 2 square plus 2 square equal R square. 2R square. 2R square. How can I tell that? This is Pythagoras theorem. 2 square plus 2 square equals 2R square. That means 2 square into root 2, root equals 2R. Okay? Very easy. R equals to 2 root 2 over 2. R equals to root 2 meter. R equals to root 2 meter. Then I can simply say Gravitational field intensity at O point from 1 kilogram. Nothing because of 1 kilogram. So I can tell GO. Let's take G equals G M over R square. That's the formula. G equals G means, let's take at G. M means 1 kilogram. R square means root square of root 2. That means G over 2. NkG minus 1. This is the gravitational field intensity by 1 kilogram. The direction of that one is in this direction. No? The gravitational field coming from the 3 kilogram in this direction. What is the value? Using the G values, we can tell that. What is the value? Yes, why? 1 kilogram, this is 3 kilogram. Therefore, this is 3 into type G, 3G. This is 5 kilogram, 5G. This is 2 kilogram, 2G. Likewise, we can simply say that things. Therefore, we can tell, let's take this one, G, 2G, 5G, 3G. From that, G to G, this cancel out, G to G. This is 2G in this direction. 2G cancel out to this one, 3G. That mean the final resultant is acting like this. This is 2G, 90 degree, 3G. Okay. Then we have to find the resultant of that one. How can we find the resultant of that? GR. GR and alpha. I can take the parallelogram. Alpha. GR. Simple G. R. GR equals square of 3G, 2G, square root. That means 3 square means 9G plus 4G squares. That means root what? 13G. Okay, that's the value. Therefore, the intensity, final answer, at O. That means GO equals to what? Root 13 G. G means G over 2. Okay, then substitute that G value. That's the answer. Likewise, we have to get the answer. Okay, then what is the value? Root 13 means 3.6. I take as 3.6. 3.6 over 2 into 6.67 10 to the power minus 11. Right? One 1.2 into 10 to the power minus 10. 1.2 into 10 to the power minus 10. n kg minus 1. This is the answer. Then you can take the alpha angle also, because why? I think this is the answer. You can substitute and get the value. I think this is the answer. Two kilogram. Yes. This is the answer. So when we find the gravitational field intensity, what is the force acting on the 10 kilogram of mass? What is the force acting on 10 kilogram of mass? The resultant GO acting on this direction, GR, we take the GR value, GO value, GO value. What is the resultant? Force acting on 10 kilogram of mass. F equals mg. F equals m mean 10 into g mean 1.2 into 10 to the power minus 10. 12 into 10 to the power minus 10 Newton. This is the answer. This is the answer. I told the 5 kilogram of mass. Okay. Then find out the another problem. Write down. Write down. Write down another problem. Find out the gravitational field intensity. Gravitational field intensity which acts on the center in brackets capital O. Okay. Find out the answer. Find out the answer. Is the problem. Thing is, we have to find the gravitational field intensity of this O point. O point. Find the gravitational field intensity of O point. Number 2, when find the force when placing 5 kilogram at O point. When placing 5 kilogram at O point. Okay, find out.
Problem. So, previously I mentioned there is a method. I take gravitational field intensity from 1 kilogram point O is symbol G. G equals to Gm over R square. Gm over R square. That means G1. What is the R value? R value we know. We know the R value are both are same. All things are same. We know the previous example also. We know 2R equals to root 2 square. That means 2 square into 2. 2R equals 2 root 2. That means R equals root 2. Previously I also tell that one. Gm over R square means root 2 square. That means G over 2. Gravitational field intensity from 1 kilogram at point O equals that one. Then we have to find the gravitational field intensity which coming from these masses. When 2 kilogram, there is a gravitational field intensity 2g, there is a gravitational field intensity 4g, and the gravitational field intensity 6g, and also 8g. Therefore, 2g cancel out to this one. Therefore, 2g in this direction. Therefore, this one cancel. This one cancel out to this one. Therefore, 2g in this direction. Finally, we have get 2g in this direction, 2g in this direction. So, what is the resultant? This is 45. This is 90. This is 45. What is the resultant? Resultant GR equals to 2g 2g sine 45. Sine 45. That mean the value 2 G mean the direction is this direction. The resultant in this direction. Why? G sine 45, 2g sine 45, 2g 4g sine 45. G mean G over 2. Sine 45 mean 1 over root 2. That means 2 into G means 6.67 into 10 to the power minus 11 over root 2. That means 6.67 root 2 into 10 to the power minus 11 n kg minus 1. This is the answer. This is the answer. What is the answer? Answer is 6.67 into root 2. 9.433 into 10 to the power minus 11, no? 9.433 into 10 to the power minus 11 n kg minus 1. Okay? Is that clear? Is that clear? The direction is upward direction, the vertical direction. What is the force acting on the 5 kilogram of mass at point O? How can we find? We have to apply second part. F equals mg. M mean 5 kilogram. 5 into G mean 9.433 10 to the power minus 11. Okay. Then what is the value? 9.433 into 10 to the power minus 11. 471. Your answer is correct, no? 4.71 into 10 to the power minus 10 Newton. Yes. Is that clear? Okay. Write down. This is the way to get the gravitational field intensity. Huh? Gravitational field intensity. Then write down. The another topic. Neutral point. Write down the topic. Neutral point. Neutral means there is no gravitational field intensity. There is no gravitational field intensity. Neutral point. Okay. Write down. Write down. A point where the field intensity is zero in brackets symbol G equals 0 is called the neutral point. There is no force on a mass placed on a neutral point because there is no gravitation force. Neutral point. A neutral point in another rule. A neutral point formed by two masses lies on the line joining line contacting them or connecting them. If the masses are equal, write down the next rule. If the masses are equal, the neutral point locate in the center of line. If they are different, neutral point is located closer to the smaller mass. Neutral point is located closer to the smaller mass. Then write down in next page, next rule. Smaller mass එක කිට්ටුවෙන් තියෙන්නේ. It's near to the smaller mass. Let's talk about that. Let's assume. Write down. Let's assume the neutral point between two masses, symbol M and 3M, is capital O. which are separated at the distance 500 meter, which are separated at the distance 500 meter. Okay, we have to find the location of the neutral point. How can we find the location of the neutral point? How can we find it? We know the neutral point is the point where the gravitational field intensity is 0. The gravitational field intensity is 0. Therefore, we can simply say if the neutral point is O, we can simply draw like this. Distance from this is x. Distance from this is 500 minus x. Okay. Then we can simply say if O is a neutral point, we can simply say the gravitational G equals 0. That means the gravitation come from this M1, G1 and G2 coming from the 3M are same. G1 equals to G2. That mean G equals G M over x square. This is mean G 3M over 500 minus x square. Okay, this is how to find out the gravitational field intensity. How to find out the gravitational field intensity? Neutral point. We have to take the x value. We can cancel out this one and also this one. Then we can simply say 500 minus x square over x square equals to 3. Therefore, we can take the root of this one. 500 minus x over x. Therefore, we have to take the root 3. That means 500 minus x over x equals root 3 mean 1.732. Okay, that means 500 minus x 1.732 x. That means this one goes to this one. 2.732 x equals to 500. Therefore, we can tell 500 equals to 2.732. That's the answer. Location of the neutral point. Are neutral point ka තියෙන්නේ කොතනද කියන එක. හරි? Location of the neutral point. So, write down. Let's do the problem. It is near to the 183, no? 500 over. To get that one, you have to use the log tables also. If you don't know to use the log table, you have to get an idea about that one also. Then we cannot use in another methods. We cannot take that one. That is very difficult to get. Okay. X equals to 183. Okay. Then write down the another problem. Quickly do this one. Okay. Then write down the problem. Write down the another problem. Find out the location of the neutral point. Find out the location of the neutral point between two masses. Between two masses. In every field, we have the neutral points. We have to find out the neutral point in electric field also. 2 into 10 to the power 8 kilogram and 1 into 10 to the power 8 kilogram. Okay. Ten to the power 4 kilometer. It is near to the smaller mass. We take x. This is 10 to the power 4 minus 6. This is practical example. This is 1 into 10 to the power 8. 1 into 10 to the power 8 kilogram. Okay. Let's find out what is the value. What is the value? AP. Let's find out. Hurry up. Find out the location of the neutral point. I need the value. What is the answer? What is the answer? Can you see? I think. Yeah. What is the answer? Okay. Then we have to find the neutral point. If O is neutral point, GA in this direction, GB in this direction. GA equals to GB. That means G M mean 2 into 10 to the power 8. R mean 10 to the power 4 minus 6 square equals to G 1 into 10 to the power 8 over the x square. So this one, and this one cancel out. So we can tell 10 to the power 4 x square over the x square equals to 2. That means root 2 equals to 10 to the power 4 minus x over x. Okay. Therefore, we can take the square root of both ends. Root 2, 10 to the power root 4 minus x over x. Therefore, root 2 equals 1.414 into x equals to 10 to the power 4 minus x. That means 2.414 x 10 to the power 4 kilometers. We have to substitute. We have to divide that one. Here, divide that one. 10 to the power 4 over the 2.414. That means 4.14 x equals 10 to the power 4 divide 2.414. That means 4.143 into 10 to the power 3 kilometers. This is the answer. This is the answer. Right? When we take in the Earth and the Moon, there is also neutral points. Neutral points. Right? Okay. Then write down. Write down the problem. Write down the problem. A mass is simple M and 3M. Simple M and 3M at placed in d distance. Simple d distance. Simple d distance. Find out the d distance. Find out the neutral point. Find out the location of the neutral point from mass of 3m. From mass of 3m. In terms of d. In terms of d. Yeah? In terms of d. This is the distance. Okay. Find out this final problem. In terms of d, you have to represent the x. Okay. Okay. Find out. We find the neutral point. We take the O. Neutral point G1, G2. G1 should be equal to the G2. Therefore, we can simply say G1 mean Gm over R square equals G3m over R square. That means x square. Okay. We have to divide it them. Then after that, we can take x square d minus x square equals 3. We have to take the separately roots. That means when we take the separately roots, we can get x d minus x. Root 3 means 1.732. That mean what? Take the answer. That mean what? That mean x d minus x into 1.732. Therefore, x plus 1.732x 1.732d. Therefore, we can tell 2.732x 1.732d. X equals 1.732d over 2.732. 2. That means x equals to the answer. What is the answer? Point 0.63 0.635 D. This is the answer. Okay. I think your answer is correct. No? Yes, this is the answer. Okay.